This is the video for the work for colligative properties. The first thing you have to do before you do any of these problems is going to be to figure out what type of chemical you're dealing with. And I have a flow chart here to help you figure out if it dissolves in water. So the first thing you have to do is I'm going to do the first four as an example, and I color coded the answers anyway, but we'll go over it. First thing you have to look at is the bond type. If, for example, NaCl, is it metal nonmetal or is it two nonmetals? Same or different, does not matter. In this case, it's a metal with a nonmetal, so therefore it's ionic, and then I'm going to have to go to table F. Once I know that, I check out table F, and then I have to figure out, does it dissolve in water or does it not? So based on table F, it dissolves in water, therefore it also dissociates because it's ionic. We would call this an electrolyte. So what I do is I'm going to write it out like this. It's going to turn into Na and Cl. They're both going to be aqueous because they're both dissolved in water, and they're both going to have charges because they broke up. Now there's a rule. Na is in group 1, so it's +1. Therefore, if I do my math, I can figure out that Cl is -1 to make the whole thing equal 0, and the problem's done. Moles of ions or molecules, in this case, it would be 2 moles of ions. Next one, Mg3PO4 twice. So this one is ionic because it's a metal with multiple nonmetals. Mg is the metal and the P and the O are the nonmetals, so it's ionic. And if I go to table F tells me it does not dissolve in water. So if I put this stuff in water, it's literally just going to sink to the bottom of the glass like a rock would if you put a rock in water, or a piece of chalk or something like that. So what's going to happen? Nothing. So that's my abbreviation for reaction. So no reaction. The amount of dissolved particles you're going to get, 0, because it doesn't do anything. So that's that outcome. Next, C6H12O6 is covalent because it's all nonmetals. If I drew the molecule out, this one I'm just going to tell you, it is asymmetrical and therefore polar. So it does in fact dissolve because water is also polar and like dissolves like, but it's not an electrolyte and it's not ionic because it's not ionic, so it doesn't break up into ions, therefore it's not an electrolyte. So this one, when it dissolves in water, it's just going to stay together, C6H12O6, and it's just going to get an AQ symbol. No charges of any kind, it stays together as one big thing, so you only get 1 mole of molecules. Okay, next, Br2. So Br2 is nonmetal. It is symmetrical and therefore nonpolar, so it does not dissolve in water. So therefore, if I put Br2 in water, it's going to sit there like a rock, or if it's a liquid, which in this case it happens to be, theoretically it would sit there like oil in water and it would just layer out, and you would get no reaction, 0 moles of anything. Okay. Now, that is how you do these problems. Now, if we wanted to rank them, right, we would say, well, the first one would have the highest. If I mixed equal amounts of NaCl molecules with equal amounts of water, this one would have the highest boiling point and the lowest freezing point. C6H12O6 would be the next highest, so it would be slightly lower, but still above 100 and still below 100. Below 0. And then these two would have no effect because they don't dissolve. So if you don't dissolve, you can't affect the boiling point. And so that's how it is going to work. I will send out a picture, or I'll add a picture of the actual answer key. I will color code it like this so you know what type of problem you're doing. There are only 4 outcomes to these problems, and they're going to look like this. Either they're going to be ionic and they will dissolve and dissociate, like number 1. They'll break up into ions. They can be ionic and they don't react, like number 2, because they don't dissolve. They can be covalent and they dissolve only. They'll never dissolve and dissociate if they are covalent. Or they can be covalent and they cannot dissolve in water, like that one. So those are the only 4 outcomes you can have. I will attach a color-coded answer key for this. I'm not going to give you the middle stuff. I'll tell you the answer here so you know how many moles of ions it breaks up into, and then I'll color code the question so you know what type of question it is, but you're going to have to do the middle part. Also, when you hand these in, eventually the work up here is going to have to be done as well.